using the Gibbs equation to predict if a reaction is feasible. So this is a question from F325, the sample paper made by OCR in 2007. The question asks you to calculate the standard enthalpy change for this reaction, then to calculate the standard entropy change for this reaction, and then to calculate the minimum temperature at which this reaction is feasible. So part 1, calculate the enthalpy change. So the enthalpy change of this reaction is the sum of the enthalpies of the products minus the enthalpies of the reactants. And the enthalpies of the products are minus 110, CO, and 0 because it's calcium, minus 635, which is delta H naught F for calcium oxide, and minus 0 for carbon. Remember that delta H naught F, the enthalpy of formation of any element, is by definition 0. If you put these numbers in, the answer you get is minus 525. Calculate the standard entropy change for the calcium oxide reduction. So the entropy change is the products minus the reactants. So the entropy of the products is CO, which is minus 197.6, plus 41.4, which is calcium. We get that from the table. Minus the entropies of the reactants, which is CaO, which is 39.7, added to carbon, which is 5.7. And if you put these numbers in, you get the answer to be 193.6. As a check, you would expect the entropy of this reaction to increase because it goes from solid and solid to solid and gas, and the entropy of a gas is greater than that of a solid. And the last part is to calculate the minimum temperature at which the reaction is feasible. For that, we need the Gibbs equation, which is delta G is delta H minus T delta S. And for the reaction to be feasible, delta G has to be less than 0. So if we set delta G equals to 0, we get 0 equals delta H minus T delta S. So if we rearrange this equation, we get T equals minus delta H divided by delta S. And we're going to put the numbers in for delta H and for delta S that we worked out a minute ago. So the value for delta H is minus 525. The value for delta S is 193.6, but the units of delta S are joules, and the unit for delta H is kilojoules. So to make this all work, we have to convert the delta S into kilojoules. So to divide this bit here, 193.6 divided by 1000, that's convert the delta S into kilojoules per Kelvin per mole. So when we put the numbers in, the number we get is 2711 Kelvin. So the answer to the question is 2711 Kelvin.